So yes, I'm Matt Tesaro, and I think AppSec is changing and needs to change, and I'm going to tell you how one of the ways I think it needs to change in this talk. At least that's my purpose and goal. And that's my contact information. Please reach out to me if you have questions. I'm perfectly cool answering questions. So just a really quick survey. Raise your hand if you're in AppSec or product engineering or maybe security engineering, or you do DevOps or DevSecOps or OppSec Dev or DevOpsec Sec Dev Ops Ops Dev Sev. So most of you, okay, cool, I kind of figured. I still don't, it's kind of interesting. I thought about this last night actually. DevSecOps. You know, if I was a DevOps purist, I'd say there are those bloody security people getting in the middle of our Dev and Ops again. And I'm not sure what the right way to work that is, but whatever. So in my mind, this is how traditional AppSec works, right? We are jousting with snails. The tools are freaking slow, they don't really work, and it's just kind of a farce. So I originally did this talk when I was at AppSec EU in London, so this felt really apropos to be quoting Shakespeare. And I like Shakespeare anyway, so I have not come to praise Caesar, but to bury him, and slightly rewritten by the AppSec Pipeline team. I've not come to praise traditional AppSec, but to bury it, right? So let's put it to bed and tell you a new way to do things. And Aaron and I did this talk together at AppSec EU. He's my co-lead in the AppSec Pipeline talk. So it's dead and buried. Let's move on. So an AppSec pipeline. One of the things I think you get when you do automation, and something you don't have when you don't have automation, because I've been in those kind of places and I've had those kind of AppSec roles, whatever, is a map of really to understand the suite of applications that you know and have in your, I don't know how many, 10, 20, 40, 1,000 applications that your company has. You don't really have a map or a guide to them. And one of the things getting security testing happening quickly and at scale gives you is the ability to at least run a baseline across all of them, right? And so this way, if you can do this fast enough, you can get this sort of general map, and you can provide the business that you're working for, where you're hopefully trying to tell them this is the security state of our inventory of applications, right? You can give them a roadmap so they know where to go and how to do things. And you can guide the business decisions with some real world numbers instead of best guesses. Like, I've looked at that code base and it's pretty scary, so I'm kind of scared about it. But I can't give you numbers because I haven't really done the work, right? So now you can give them numbers. All you need is a plan and the roadmap and the courage to press on to your destination. So let's do that. So here's an AppSec pipeline. If you've seen me do this talk before, you've probably seen this. Aaron and I whipped this up a couple years ago. The big idea here is that you have some sort of request coming in from some source. That could either be a human, or it might even be, say, a GitHub hook, a commit hook, right? But you have some sort of request come in. You need some way to handle and triage those requests. You're going to have some number of tools that are automated in the middle to run these things. Ideally, you're going to take the output of all of those tools and put it into one single source of truth, right? This vulnerability repository. That way you can normalize the scanner data, because if you've ever looked at scanner output, all of them are very snowflakey and different than the other ones, which makes summing them up and doing comparisons rather tricky. And then once you have this single source of truth, you can do things like pull stuff out into a defect tracker. If you have a GRC tool, like you actually bought Archer and installed it, instead of sitting it on a shelf, you could actually push that stuff to Archer, right? You can do reporting and metrics. If you haven't tuned these tools good enough, or for some reason you can't tune them good enough to remove false positives in this stage, you could go in and manually remove false positives in a second place. There's sort of two places to catch false positives, right? Ideally, too, you will push these into the defect tracker that your dev teams use and have them have the same workflow for issues that are functional and security, right? Because you don't want to do the chuck the PDF over the wall thing. You want to actually hand them actionable findings in whatever format they're used to seeing functional findings, right? So that's a very quick overview of the AppSec pipeline. So the next sort of thing, and I should back up, this was the first pipeline that myself and actually Aaron at the same time, we were working at the same place. We set this up initially where we were working. And this was really very inwardly focused. When we got there, there was really no AppSec program really to speak of. There was a sort of a very nascent one. And a whole bunch of businesses had come together. Bits of a business had been, 8 different pieces of a business came together to make one big corporation when we got there. So we were the center of excellence for AppSec, whatever. But there was absolutely no rhyme or reason to it. So this was really focused on making our internal team work well. It was a very inwardly focused pipeline. Like this was really meant to be used by the AppSec team for the AppSec team, so we were quick and efficient. Once we got that down, we started reaching out to the teams that were doing DevOps and dropping now tools into their CI/CD pipelines that would not only red green for them, but would also send the information back to our pipeline, so we were getting visibility into what was going on with those other teams. So we've sort of gotten our house in order, and now we're reaching outside and interacting with teams. Because to be honest with you, if we tried to do this kind of thing before our house in order, we would have been a mess. Because we were a mess, right? Until we sort of figured things out and got it sane. So what is an AppSec pipeline? It's a way to do conduct testing in an automated fashion, and it's really initially should be run by the AppSec team for the AppSec team, right? Because the idea of the AppSec team or the product security team or whatever you call yourself is to find out the state of security of that suite of applications. So you really want your internal processes to work well so you can do that efficiently. The other thing is, it's a great way to sort of get your house in order before you start reaching out to other teams, because if you're a mess, like I said earlier, your interactions with other teams is going to be a mess. But the really big thing is, this is about you must be this high to ride the ride. This is not thorough, in-depth, I took a week pen testing your thing. These are quick, lightweight tests. They're not perfect, but they give you some sort of visibility across your entire suite of applications as opposed to knowing these two really well, and I have no clue about the 50 others. The other interesting thing you can do if you do have this automated testing is when you do manual testing, you will have already done a lot of the types of tests in an automated fashion already. So if you have 50 things, let's say, you check for in a manual test, maybe 25 or 30 of those you've automated. That's a large portion of manual testing you don't have to do. Because if you're running them all the time, and I'm now going to manually test that app, I just have to go look and see the last time it ran, what was the state? Oh, here's the SSL ciphers. Yes, it had those correct headers, right? All those kind of grunt worky kind of things you do in a manual test, just let the automation do it for you. And then if you do this across your suite of applications, now you have a baseline. And you can do relative measures of the sort of code smell, for lack of a better word, across your suite of applications. And you can start making rational decisions that, yep, this one is high risk and it's really noisy on the scanners, therefore I'm pretty scared about this one. This one's also high risk, but it's really quiet on all of my tests. And looks generally pretty good. I'm maybe not going to worry about that one as much, right? But until you get that broad view, it's really hard to make those informed decisions. So what isn't an AppSec pipeline? It certainly isn't the magic pixie dust that's going to solve all your problems. I can promise you that. Like, I'm not here to sell you, like, I don't know, some magic beans, right? And I don't think it should be at first a gate that blocks any kind of deploys to production. One, when you're first setting this thing up, you're learning as you go. And two, this is more about just getting visibility into the state of things. And until you're really sure that you're not going to false positive, I wouldn't go anywhere near pushing this stuff out or making it be a gating function, right? That's politically a very expensive thing to do on a false positive, right? If you want to get yanked out of somebody's CI/CD as quickly as possible, give them a false positive and break their build for a bad reason, right? That is like asking to leave the room, right? Don't do that. And then if you want to think about pipelines, if you think about CI/CD in a traditional sense, the artifact of a CI/CD run is some sort of deployable thing, right? Either an actual deployed app or maybe a RPM that you can go drop on a server or something. It's a deployable artifact. For an AppSec pipeline, the artifacts are findings, right? Those are findings that say, I found this security issue with this app at this time. So here's another example AppSec pipeline that we're actually working on setting up at OWASP right now, where we'll have a project repo. I'm actually not going to use Jenkins, to be honest with you. I'm going to use something else I'm going to talk about in a few slides, but I spent way too long making this cool looking graphic to not use it. So I'm using it because I did that bomb thing and made his finger work, and I'm bad at graphics. I'm proud of that. Magic that I did that one time. Anyway, I'm going to have automation actually launch some Dockers, run some tools against those Dockers, push all the findings to OWASP Defect Dojo. For those projects that have Jira, we can push issues to Jira, and then there's also push issues to Slack channels. There's Slack and HipChat integration and Jira integration all in Defect Dojo, so I get that for free, so I'm going to use it. Like, why not? Oh, and as you go out and get swag from the vendors next door, please go out and ask them for a reasonable REST-based API to interact with so you don't have to log into one more frickin' web interface. I'm sick of that, and I'm tired of having 12 of them to do my job. So please, please, please bug vendors for APIs. It's getting better, but it's still not great. So, GASP. GASP is a Golang application security pipeline, and it was Aaron and I had been talking about the pipeline and how to do better automation, and we've done some automation, and we were trying to sort of get our minds around it from a higher level to understand how this thing should work. Well, anyway, let's just go forward. So GASP, it's a Golang application security pipeline. This is, my daughter drew this Golang gopher for me because, like I said, I don't do graphics, so there's my logo. Thank you, daughter. Josie, rock on. What we came up with is under the GitHub, we have an org called AppSec Pipeline. Under there, we have a specification, GASP, which is a Golang implementation of the library behind that specification. And then another tool I'll talk about in a couple minutes called GASP Docker, which uses Docker to launch containers that have security tools in them. And all this is up on GitHub. So the specification. So Aaron and I had done this, well, we did this together at one employer, and then we had both done it at other employers, and we were talking through like what it took to get these things to work and where we busted our knuckles and where we hadn't, and how to make these things better. And we sat down and wrote an actual spec about how we think these things should work. Because I've done talks similar to this for a while now, and I mean, I thought the talks were useful, but one of the things that was unfortunate was because everybody's app team and the way their applications are built are very snowflakey, I couldn't give you the concrete implementation, like go do this thing, right? If you do these 7 things, magic happens, because you probably do things differently. So we wanted to have sort of a conceptual framework to explain how to do a pipeline in general, because how I do my pipeline works great where I'm working, but it might not work great where you're working, and you have many different tools and situations that you have to deal with. So this is sort of a generalized way to think through that problem. I did a sequence diagram, so you can actually look at the steps and how it all works. And what we ended up with is this. An idea, we have some sort of event happen, right? This could be a commit to GitHub. This could be the CISO comes down and says, hey, I want you to do a quarterly assessment of this application for PCI, whatever it is. Some event happens, right? The AppSec pipeline learns about that event. It's going to launch one or more Dockers that have tools in them that will then go into interrogate one or more targets, right? Those tools will run, they'll find or not find things about those targets. The results will go back up to the AppSec pipeline. And then in my case, I drop them into Defect Dojo. That's my source of truth, right? Pretty straightforward and very, very scalable, right? If you do this on something like ECS, you can launch as many containers as you feel like paying for. Really, there's sort of not an upper limit. So one of the really interesting things about containerizing these tools is you treat them like binaries. It's almost like having, say, the Nmap binary on your system and you just run it. Even though it's an actual container, it doesn't really matter. They end up being like running binaries, and you just run and discard them. The way the pipelines I've set up work is you launch a container, it does its work, and you trash it, and it goes away. They're not long-lived. They live for 30 seconds. They don't live for days. And you put one tool per container, right? So you make the Zap container, you make the Bandit container, you make the Retire.js container, right? You have all these containers of tools. And now you can a la carte run them and mix and match them as you need to based on what kind of testing you're doing. And then each container has a YAML file that explains what those tools are. And then a second YAML file contains the profiles of how you want to run those tools in what order. And we'll talk through each of those in a second. So here is the pipeline tool YAML. This is the file that explains what tools are available to the pipeline. It's basically your inventory of tools. So you have things like, this is for the AppSec version 0.5, it's Bandit, it's static code analyzer, it does Python. Here's some links for reference. Parameters, so there's certain things you need to know to be able to run Bandit. One of them is the location of the source code. So this parameter is required to run this tool, it's LOC, and it's the location of the source code, right? And then when I'm running it, here's the command I'm going to exec. It's going to be Bandit. It's in a shell. I do -v cvs-o report name. The things in the squiggly braces get replaced out at runtime. And so the report name is going to be a timestamped CSV. Post, after the thing executes, we're going to run this post little tool because Dojo wants it in a particular format that isn't the format that this tool does. So we have this little bit of stub code to munge the format into a friendly to import format. Aaron also was doing some JUnit stuff, so he wrote an additional thing to convert it into JUnit test results. I don't personally do that, but whatever, it works for Python. And then, oh, I don't have profiles, so interesting. Oh, it's cutting it off. Oops, well, that's not good. Here's another Git example, right? So I have Git tool, here's the Git, here's the Docker I'm using for Git, here are the parameters I might need for Git. I'm going to execute Git. Unfortunately, I had a 4x9 slide and it got cut off on the bottom. At the bottom that you can't see, let's just pretend. There's a thing called profile, and these are how you're going to run the tools. So for example, for Git, you can do a clone profile that basically just does a Git clone of master, or you can do a tag profile where you can pull a particular Git tag out and clone that tag into wherever we want the location of code. So for example, combining Bandit and Git, you could say, I want to pull out this version of my code out of Git, put it here, and then have Bandit go and look at that code in that location, right? That's the LOC that I mentioned earlier. So there's 19 tools currently available in the GASP Dockers GitHub repo. You're welcome to use those or be inspired by them. They're just up on GitHub. Go have fun. What do you get from the benefits of containerizing all these things? The biggest thing is a lot of these security tools, like they're neat and they work well, but sometimes they're, let's just say, interesting to install with uniquely vague install instructions. So that fun and excitement of trying to figure out how to install that thing happens once, and then you have a Docker with it and you don't have to think about it again. That's actually quite nice. The other thing is you only have to sort of read the man page once and figure out all those weird command line switches and what the hell do I need that one time, and then you can codify that into a profile. So if you know, generally speaking, these 3 command line options are all I need to make Bandit work like I want it to, you make a profile with those 3 options and you don't have to think about it again. The tools can be in any language as long as you can Dockerify it, which is perfect. And then if you run the same tool across all of your suite of applications, like say for Bandit, if you have a bunch of Python applications, you run it across all your Python things, now you have a baseline. And you can make relative measures of the risk or the vulnerability-ness of your applications based on those tool runs. And another bonus that isn't on this slide is that those same Dockers, if you have devs that want to do it, can go pull those same Dockers and run those same tests against their code before they even hit your CI/CD, right? Because it's just a Docker. Like, give them the Docker. You want to know what tests you're going to have before we push this thing to production? Here's the 3 Dockers we run with this way and done. Right? So now if the devs want to, they can even pre-test before they go through any kind of QA/QE. So, named pipelines. So if you take these Docker containers that we've had and you add them together in a sequence, you get what's called a named pipeline. So think about it as, I've got several things I want to do to test, say, a Ruby application. I'm going to pull the source out from Git. I want to run clock to get an idea of what kind of source code is in that, say, Rails application. Then I'm going to run Brakeman against it, because that's a Rails application checking bit of static analyzer. And then at the end, I want those results in Defect Dojo, right? This is generally how I want to treat my Rails apps that I interact with, and I've decided this is a good way to do it. I can create what's called a named pipeline. You just put a label on it. So we're going to call it Rails SAST in this example. And now anytime I have a Rails app, I just tell the pipeline, hey, go run Rails SAST against it. And it knows the order and sequence to run these things. So here's an example of the AppSec Pipeline config file for those named pipelines. So we have a named pipeline called source code. Man, is this? Oh, this is better. There we go. I got to zoom in. We've got a named profile called source code. This is YAML. It will actually read the startup section first. So the startup section is going to run git with the tag profile. If it, for some reason, doesn't or isn't able to pull that code out of the repo, it's going to just fail, right? Because there's no reason to keep executing the rest of these Dockers if I can't get the source code. So this is sort of an early way to break out of this run. And then clock, the same thing. I'm going to run clock. I'm going to run the all profile that just gives me all of the source code out, or counts of the source code out. And if this fails, we're going to fail. Then afterwards, we're going to run the pipeline. That's the second step, which is going to be check marks, and we're going to run the all profile. And then this idea is that, let's say for check marks, we only want high. We don't care about mediums and lows in this particular case. So this will tune out anything except for high results. Then we're going to run bandit, brakeman, retire JS, depending on what clock finds out. And then in the end, we're going to run the final section, which is going to shove all that stuff into Defect Dojo and done. So at the end of the run, I have all of the results from the scan in Defect Dojo. And that takes, I don't know, I did a training on this Tuesday and Wednesday, and we did an example in class, and it took 30 seconds to pull from Git, run bandit and clock, and then push it into Defect Dojo. So it's pretty quick. It's crazy quick. One of the things Aaron's doing where he's working is he's actually pushing these things to a Slack channel. So he actually has the stages of his pipeline runs pushed to his team channel. So the team can see as it's going on what's happening. So we can actually get a live status of each run of his implementation of the AppSec pipeline. GASP is a library I mentioned. It's in Golang. That's the library I used behind GASP Docker. It's up on GitHub, as well as GASP Docker, right? That is another. It is a implementation using the GASP library that locally runs Dockers on, say, your laptop or a server, and it will launch those Dockers according to the named pipeline you create and push all those tools if you want to into Defect Dojo. Or you can do a different final step if you want them to go somewhere else. So here's a real-life implementation of an AppSec pipeline. This is the one that Aaron is working on currently, where he has a developer checking in code into Stash. That Stash sends a webhook to his AppSec pipeline. When that happens, he fires up Docker and a bunch of different Dockers to test that code base. When that's done, he writes the results to Defect Dojo. He's pushing those results to Jira, and also pushing a summary in the Slack channel to that development team. For his AppSec pipeline, he fronted it with a very lightweight REST interface, so now it's just a matter of curl or REST calls to get these pipelines to fire, so it makes integration ridiculously simple. I would highly recommend doing a REST API in front of any kind of pipeline you do, because we just love automation. He's running this on a T2 large EC2 instance. The criteria for the tools, they do have to run pretty quickly. So if you have a long-running tool, you may consider making that asynchronous or just not running it as part of a fast pipeline run. Static scans with differentials are usually a way to get around that, particularly with some commercial tools. Third-party component scans, the open source libraries or the dependencies or whatever you want to call that, those also tend to run pretty quick, so those are good things to automate. With his pipeline, he's got 15 repos. He's done 5,100 runs in 4 months and had 2,500 plus container executions, because these things are just throwaway containers, right? Launch them, run it, throw them away, done. And the way the pipeline works is, at least the implementations I've made, is I launch a Docker volume inside of that Docker that holds the results, and that's what passes the source code or what have you from one tool to the next, because that volume just gets shared into the end and then destroyed. Or you can write it off to a different file system, whatever you want to do. So Aaron has been adding a bunch of stuff to Defect Dojo, such as CI/CD information inside of CI/CD engagements. So you can now track things like the build ID and the commit hash and the branch and all of that happened against your particular run. Because as we started doing this more and more, we realized, well, oh shoot, we need to track what branch this worked at so I can repeat this test and all those kind of things. So we started adding that metadata back into Defect Dojo. So now, like I said, you can actually get all this. Like, this is a link out to the Bitbucket server, and that's the Jenkins dev server that is firing off this job, and all of that is now tracked inside of Defect Dojo, so you can sort of understand exactly what environment that test ran in. And then this is an example of, like, this is the merge git commit log that came in, and this is the result of that merge. So webhook happens. With this commit log, these tests fire and we find these issues. These are the current code tools -2 that don't have logos that I could find. The Defect Dojo will automatically import. think it's 24 tools, which is somewhat handy, both application and infrastructure. So what have we learned? After the first few scans, the vulnerabilities tend to go low. So it will take you a couple of runs to get this thing to not be as noisy as it is when you initially start. Some ways to get rid of that noise is to do things like tuning the profiles of the tools. And at least at Pearson, when we were trying to get this done, for the highest risk, we basically categorized the apps into 3 different categories: high, medium, and low risk. For the high risk, we actually took the man hours to run this multiple times and tune the profiles, particularly with the commercial tools, where you do need to do some profile tuning. So that at least for the high-risk apps, we had really high confidence. For the medium-risk apps, it was a best effort. If we had the bandwidth at the time, we would tune it. Sometimes we just wouldn't, because we just didn't. And then for the low-risk apps, to be fully honest with you, they were just self-serve. Like, I'm sorry you get the default profile. We don't have the bandwidth in humans to deal with tuning the tool. Legacy security tools will be your biggest pain points. You saw check marks up there as one of the tools. That's not a Docker that has all of the checkmark engine in it. That's a Docker that has a shim that knows how to reach out to actual checkmark's mothership and fire off a scan. And you're gonna have to write a lot of these shims, and depending on how easy or not easy your vendor's tool is to automate, that shim could be really, really interesting or not. So there is going to be a lot of this sort of glue code mess you're going to have to do to interact, particularly with the commercial tools, and even some of the open source tools. Like Bandit, I think it was Bandit, one of the tools I automated, if it had findings, it put them in standard error, which in Docker world means Docker exits because it thinks it errors. And I kept having my Dockers die, and I'm like, WTF, like this one run without errors was fine, and then this one died, and okay, I had to like work around that issue and wrap it in something that handled that standard app, right? Those kind of are standard error. Those kind of dumb things you're going to run into. You're going to have to do a little bit of massaging. But legacy tools are the most fun ones. And then evaluate what you did and just keep improving. Like, we iterated like hell. I mean, I get to show you the nice, pretty slide at the end of the day that we did, but our first pipeline, when Aaron and I worked together at Pearson, took 3 months to get the initial one stood up, of myself and another engineer building it out. So don't think you're going to get the happy magic in 2 days. You won't. Right? It will take some time, but if you build it to grow iteratively, we went from, what was it? It was 44, I think, assessments in year 1 to 200 assessments in year 2 at Pearson by doing this automation, because like all the stuff got quicker. And then false positives. There's 2 ways right now you can deal with false positives. I mentioned them earlier, right? You can tune it out of the tool, ideally, right? But if the tool doesn't give you enough knobs and bells, or just it doesn't work, you can also tune it out at your source of truth, like Defect Dojo, right? You can also write things for Defect Dojo to tune those out. Right now in Defect Dojo, you have to mark something as a false positive and then tell Dojo, in future, when I get this result from this tool against this app, keep marking it false positive. But that's a manual thing. It'd be nicer to be able to do some of this automatically. And so the new release of Defect Dojo that's probably about 2 weeks out is going to have this thing that they're calling a rules engine that lets you look at imported data, analyze it, and apply some rules. So for example, you can do things like, if I get XSS, I want to match it to CWE 79 instead of whatever the tool says, right? Because some tools will call this CWE, I don't know, 15, and others will call it 72, and we just want them all to be 79. So you can do those kind of coercions. You can also do things like, if the scanner is SSL Labs, and SSL Labs tells me their cert setup is an A grade, I'm going to head and mark those as verified, which means I trust those results. Like, that scan is good. I don't have to go back and have a human verify those results. If the scanner confidence is confirmed and the title is cross XSS, like I trust this scanner's finding of cross-site scripting, then go ahead and mark it verified. I don't need someone to check those, because I've done this enough that I'm good with how that scanner works on my particular app in this situation. I need a drink. So I read a very interesting article about this iceberg of ignorance. I would Google it and read it if I were you. But the idea here was that as you go up the management stack, you're further and further away from the front line where the reality is. And so the problems get less and less obvious and less visible as you get further away from them, because there's, if nothing else, there's that whole thing about whispering across the classroom, and I tell her that I like cats, and at the end, we're saying something about hippopotamuses, right? Like, the story's gonna change as it shifts more hand. So, one, that's a great lesson, I think that's true, but I think with security, automation and continuous security, you can actually drive that visibility up, because now we can produce real summary numbers across all of our apps that's in a consumable fashion for management, right? If I can say, I ran a baseline across all of our apps, and by the way, I made a scale of A, B, C, D on all of the apps, and I can give them grades. Now you have something you can talk to a CISO about. Like, we have 7 apps that are graded A, and 12 apps that are graded C, and 2 apps that are graded B, whatever your numbers are, right? You can start to actually push that stuff up in a way that's consumable to upper management. And then Finding Nemo, right? Anybody who has kids has seen this movie, and you don't even have to have kids to see this movie, right? But that's Finding Nemo, great movie, right? And there was 3 sharks, Bruce, Chum, and Anchor, right? Who were trying to reform themselves, right? And they had this little mantra they were saying, right? I'm a nice shark, not a mindless eating machine. If I am to change this image, I must first change myself. Fish are friends, not food, right? Awesome. Well, I think we need an AppSec mantra with Bruce. I am a nice security professional, not a mindless vulnerability spewing machine. If I am to change this image, I must first change myself. Developers are friends, not fools. So if you're with Bruce, we got a hashtag. No, oh, here, take a picture. I'll leave it up for a second, take a picture. But if you're with Bruce, please, you know, we got a hashtag and a Twitter thing, so make it happen. And that's it, I'm done. Going once, going twice? Awesome, well, thank you very much.
And